Today we're going to talk about quadratic equations. This is SV Math Teach, about halfway through Chapter 4 and about halfway through the school year if you're in algebra. Well, maybe not the school year, but about halfway through the content we're going to study. And reviewing a couple basic things here with you. First, we're going to be talking about quadratic equations. And quadratic equations are equations that have, well, exponents that make them quadratic. So they have squares in them. Sometimes they're going to equal a 0, and sometimes they're going to equal f of x, or g of x, or h of x, or they might even equal a y value, and that's okay too. We're not scared of that. But I'm going to show you two different techniques for solving. And the first one is going to be factoring. In lesson 4.4, we talked about a review of factoring. So if you need that, you can go back and look at a simple review of factoring. We're going to talk about graphing as well. And I believe that's, gosh, maybe 4.2 or 4.3. You can go back and you can look at some graphing stuff as well. I'm going to do a quick demo of both of those, but I'm going to keep it quick. So let's start with this concept of factoring first. And using factoring to solve a quadratic function means we're going to change the quadratic function a little bit. Instead of f of x or y equals ax squared plus bx plus c, we're going to artificially choose a number 0 in place of y. And we're going to rewrite these problems as ax squared plus bx plus c. And then what we're going to attempt to do is we're going to attempt to factor that trinomial into two binomials. And sometimes it'll have a GCF out here, so you might have a number on the front, or you might not. But what we're going to do is we're going to attempt to factor those. And if we do, we're going to use this thing called the zero product property. The zero product property. And what that means is if we have a 0, that is the result of a product, right? Product means two things being multiplied together. So if we have a 0 being the product of two things being multiplied together, the zero product property tells you that the first item or the second item, one or both, have to equal 0 because that's the only way to get 0 out of a multiplication problem. Okay, so we're going to use that right now in a question that we're going to solve with factoring. And then we're going to solve, as you can see, we're going to solve it with graphing as well in just a moment. But let's go ahead and solve this with factoring to start with. I'm going to get all of the terms on the same side. And I'm going to leave a 0 on the other side because that's how the zero product property works. So step 1 is move everything to one side and leave a 0 on the other. Second step is let's factor. And I see the 2, 6, and 4 have a common factor, so I'm going to get rid of my GCF. And now I'm going to factor this trinomial. And 1 times 2, they both have to be positive. And here we go. So here we go with the zero product property. The zero product property says there are 3 items here, this one, and this one. And when multiplied together, they produce a 0, right? Product of 0. So if they produce a product of 0, one or more than one of them need to equal 0 in order to get a 0. So I'm going to set up each of the terms, not equal 1, equal 0. So 2 equals 0, x plus 1 equals 0, or x plus 2 equals 0. And 1, 2, or all of those may be true. We're going to consider them all solutions, except one of them doesn't make any sense. This one's kind of a ridiculous one, right? 2 equals 0 is a non-starter. So we're going to not use that one. But we are going to include these other ones like x is negative 1. And notice how I'm just solving these. And x is negative 2. So I'm going to go ahead and say that we have two solutions. X is negative 1 and x is negative 2. And that would be my two solutions. All right, so that's solving by factoring. Get everything on the same side, factor it, set it equal to 0, and then see what you get. Now, if you want to do a more visual version, you might be choosing to solve a quadratic equation with graphing. And with graphing, you might see it equal to 0. If you do see it equal to 0, like in the previous question, we actually swap out the 0 for a y. Or if you prefer, like an f of x, because we want to have two variables so that we can graph on an ordered plane. So here's what you're looking for when you're done with your graph. You're looking for spots where your curvy line, your parabola, touches the x-axis. And you'll see in my example here, my parabola touches at 2 spots, so I have 2 solutions, otherwise known as 2 zeros. All right, the zeros are going to be another word or words that we can use for solution. So let's go ahead and check out how we do that. This is going to be a very brief reminder of graphing, and then I'm going to show you Desmos as well. I have this set up here. I got to tweak it just a little bit from the previous cut of this video. let's take out this, and let's go ahead and see what we have here. I have this 2x squared plus 6x equals -4. I'm going to put everything to one side. I'm going to set it equal to y, so 2x squared plus 6x plus 4. I need a little space here, so I'm going to go -b over 2a, so -6 over 2 2's is 4, so -1.5 is my x value of my vertex. If I plug that number in, let's see, 2 -1.5's squared plus 6 -1.5's plus 4. So let's see, that's going to be 4.5. That's going to be -9. That's going to be plus 4. Let's figure out what it equals. And y equals -0.5. So what I think I have is a vertex of -1.5 and -1.5 and -0.5. So if these are one space each, you know what, let's do this. Let's change this paper if we can. Maybe we cannot. I guess we cannot. There we go. I thought I could change the paper to something a little bit easier to work with. Maybe I'll take this out in post-production here. Let's see what we got. And maybe not. So -1.5 is about here, and -0.5 is probably about there. So that's where I think my vertex is. Now, I don't know that I can draw a terribly accurate graph based on just that one dot. I do see a couple basic things. I see like my a value is positive, so I know it's going to open up like a bowl. It's going to look something like this, but we can probably be a little bit more accurate. Let's go ahead and throw down, imagining this is my axis of symmetry, which it is. Let's just do a point to the right of it. Let's see what happens when I put -1 in, and let's figure out what happens. So let's see, y is 2 -1's plus 6 -1's plus 4. So that's going to equal 2 minus 6 plus 4. So y equals 0. All right, well, that's easy. So if I put a -1 in, I get a 0 back. So that circle that I picked, actually kind of by dumb luck, actually ends up being there. And because of symmetry, now I know this one exists as well. And my graphing is done, actually. Now, while I don't have a great graph up here, what I do have is I have my 2 points. Right here is my parabola, something like that. And I have my 2 points that touch the x-axis, one of them at -2 and one of them at -1, which is exactly what the other side told me when I solved it with factoring. So I think we're good, right? We have 2 solutions. And just because it's fun to check in lots of different ways, I happen to have graphed the same thing in Desmos. I'll even tap the, oops, I just lost them. So there's the point on the left, there's the point on the right, and there's the vertex to kind of confirm that we did it correctly. Right? So we're in good shape there. One more time. Point on the left, point on the right. Those are my 2 solutions, otherwise known as zeros. And my vertex is at the bottom. So what I hope you learned in this short video, or not too short video, is there's 2 ways to solve right now. One way to solve a quadratic function is with factoring and the zero product property. And the other way is to look for points on the graph where your parabola touches the x-axis.